Implementation of a partially self-sufficient energy supply from renewable sources for large consumers, e.g. airports, steel mills, etc. This is only possible if one of the following patented systems is to be used: the Zired compressed air storage system, ZCASS, or the gravity storage system, ZGASS, or the hydroelectric storage system, ZHASS. Preliminary example calculation for a partially self-sufficient medium-sized airport, grid-connected or off-grid, with redundant emergency power supply based on fossil fuels. Facts: the electricity consumption of a medium-sized airport depends on many factors, such as the size of the airport, the number of passengers, the number of aircraft movements, technical equipment, and the efficiency of the energy supply. However, a medium-sized airport typically consumes between 50 and 150 gigawatt-hours of electricity per year. Influencing factors: 1. Terminals and buildings, lighting, air conditioning, escalators, elevators, and other electrical equipment. 2. Aircraft handling, power for aircraft docks, ground power, instead of APUS, and baggage handling systems. 3. Runways and taxiways, lighting, signaling and electrical systems. 4. IT infrastructure, servers, communication systems, and security technology. 5. Retail and hospitality, power consumption of shops, restaurants, and other services. An airport with 10 million passengers per year could consume approximately 100 gigawatt-hours of electricity per year. This corresponds to an average electricity consumption of approximately 11,400 kilowatt per hour, 100 million kilowatt-hours/8,760 hours. A medium-sized airport consumes approximately the same amount of electricity as 20,000 to 30,000 households, assuming an average household consumption of 3,500 kilowatt-hour per year. To achieve an annual production of 100 gigawatt-hours, we need to calculate a mix of solar panels, wind turbines, and Zired solar thermal power plants based on their average output and local conditions. Here is a simplified approach. 1. Solar panels. Average power of a solar panel. A typical solar panel has a power of about 300 watts, 0.3 kilowatts, full load hours. The number of full load hours depends on the amount of sunlight. In Asia, for example, about 1,200 to 1,800 full load hours per year is realistic. Calculation: annual production 40 million kilowatt-hour. Power per solar panel 0,3 kW. Full load hours 1.600 H. Number of solar panels 40 million kilowatt-hours / 0,3 1.600, 83,334. Result: to produce 40 gigawatt-hours per year, you need about 83,334 solar panels. 2. Wind turbines. Average power of a wind turbine. A modern onshore wind turbine has a power of about 3 MW, 3,000 kilowatts. Full load hours. Onshore wind turbines in Asia have about 1,800 to 2,000 full load hours per year. Calculation: annual production, kilowatt-hour, 40 million kilowatt-hour. A power per wind turbine, HOTS, 3,000 kilowatts. Full load hours 1900 H. Number of wind turbine 40 million kilowatt-hours / 3.0001.900, 7 HOTS, horizontal axis wind turbines. B power per wind turbine, VAWTs, 100 kilowatts. Full load hours 1900 H. Number of wind turbine 40 million kilowatt-hours / 102.000, 200 VAWTs, vertical axis wind turbines. Result: to produce 40 gigawatt-hours per year, you need about 7 wind turbines, HOTS, or about 200 wind turbines VAWTs. 3. Zired solar thermal power plant. Average power of a Zired solar thermal power plants. A Zired solar thermal power plant has a power of about 3 MW full load hours. The number of full load hours depends on the amount of sunlight. In Asia, for example, about 1.500 to 1.800 full load hours per year is realistic. Calculation. Annual production, kilowatt hour, 40 millions kilowatt hour. Power per Zired solar thermal power plant 2.000 kilowatts. Full load hours 1.600 h. Number of Zired solar thermal power plants 40 millions kilowatt hour / 2.000 12. Result. To produce 40 gigawatt per year, you need about 12 Zired solar thermal power plants. Summary. Solar panels, about 83.334 solar panels. Wind turbines, about 7 watts. Wind turbines, about 200 VAWTs. Zired solar thermal power plants, about 12 Zired STPP. These numbers are highly dependent on local conditions, sunlight, wind speed, and the efficiency of the technology used. In practice, the actual numbers may vary. Our recommendation is the use of HOTS, VAWTs, and Zired STPP. Zired Compressed Air Storage System. ZCASS. Example design capable of having a storage capacity of 200 MWh up to 2 or more GWh. Underground compressed air storage tank. Example of an underground compressed air storage system. Zired Gravity Storage System. ZGSS. Example design capable of having a storage capacity of 200 MWh up to 2 or more GWh. Underground gravity storage tanks. Zired Hydropower Storage System. ZHSS. Example design capable of having a storage capacity of 500 MWh up to 10 or more GWh. 2 natural or artificially created basins of water with a water level difference of at least 50 meters. The three Zired storage systems are characterized by the following features. Demand-driven power generation. Cost-efficient and fully sustainable construction using environmentally friendly materials, quiet machinery, and non-toxic components for seamless integration into residential buildings or underground facilities. Simultaneous variable energy storage with stable 24/7 power output. Extended emergency power supply to maintain electricity production for days to weeks during temporary unavailability of renewable energy sources. Use of lightweight components with Zired compressors/motors weighing between 100 and 300 kilograms. Self-sufficient operation possible under certain conditions. Simplified and robust design for easy installation and low maintenance. Ensuring district heating and cooling supply for communities via the compressed air system. Applying the principle of fluctuation compensation to stabilize energy production. This means that renewable energy is first stored and then used to produce stable electricity. Outstanding cost efficiency in terms of price-performance ratio.